Okay, so again, there was sufficient evidence to support that the hypothesis that over half of the customers are comfortable with drone deliveries. Now, if you look, there was two methods here that we could have used. First, the p-value method, which suggested that the p-value is 0.0054 from that statistic value that we calculated. And that value is less than 0.05, which constitutes a rejection, right? That means we're in the tail, and that's the rejection region. Now, our critical method suggests that our z value was 2.55, which is greater than 1.645. So our z value is greater than 1.645, essentially putting us in this rejection region. So we could reject the null hypothesis and constitute that there's evidence supporting the alternative hypothesis. Right? We can't conclude that the alternative hypothesis is fact, but we can reject the null hypothesis and we have evidence to support it. So you can test the claim using a confidence interval. A lot of students have learned the confidence interval method and used it for every single one of their hypothesis tests. So don't worry about what's over here. We're not going to discuss this. Let's talk about this right here, right? So for my confidence interval, okay, of 0.05, we can use the 90% confidence interval. Okay, so P plus or minus our error, which is P hat plus or minus Z alpha over 2 times the square root of P hat Q hat all over N. Okay, so this is what we would use here. Again, Z would be Z alpha over 2. Okay, so suggest we have a confidence interval of 0.514, which is less than P, which is less than 0.566. That means that the population proportion has to be in between 0.514 and 0.566 to a 90% level of confidence, right? So how do we conclude? Because we are 90% confident that the limits contain the true value of P, we support the claim that P is greater than 0.5. Okay. Again, that's because our confidence interval, when we ran this test, put us in this region, which suggests that the true population proportion, based off of our numbers, is between 0.514 and 0.566, which is greater than 0.5, which tells us that our population proportion is, could be greater than 0.5 with a good amount of confidence. So we rarely use the confidence interval test because it has different results from the p-value and critical methods. Okay, it can happen. You can have different results. So try to stay clear of it. When using technology for hypothesis tests of proportion, we enter the sample size and we enter X, the number of successes. Okay. This is really N and P hat. Okay, if you think about it, sample size and the number of successes, we're giving the computer or software N and we're giving them P hat. That's computed, and then a test is ran. So here's an example